Let's take a look at how to graph one period of a tangent graph. Well, the first thing I'll probably want to note are my A and my B values. So my A is 2, my B is 3. Now the A we've talked about is not the amplitude, unlike the sine and cosine graphs, although that too will have an effect on my graph when I get to that point. B is not the period, but it helps me find the period. To find the period of a tangent or cotangent graph, it is pi, the normal period, divided by the B value. So in this case, there's nothing I can do to simplify. The period is just pi over 3. Also, I'm noting that there's been no reflection going on here since my A value is positive, and the graph has not been moved up or down. There's nothing that's been added to this graph. So let's go ahead and take a look at how we're going to actually graph this one. The tangent graph is different than the sine or cosine graph because this is the first time we're actually going to see part of the graph to the right of the axis, or the origin, and part of the graph to the left. So the graph kind of straddles the origin. There's half on either side. And the way that's going to affect how I find my tick marks is when I go to place the ends for the x-axis, it's not the full period that's going to be over here. It's just going to be half of that, since half will be to the left and half will be to the right. So half of the period, half of pi over 3, is actually just pi over 6, which is going to be this tick mark over here. It'll be symmetrical, so this tick mark over here will be just negative pi over 6. It's half the period. I'll go ahead and label the 0, and then I also want half of the halfway point. So half of pi over 6 is pi over 12. You can use a calculator if you need help doing that multiplication. And because we're symmetrical, that's going to be negative pi over 12. So they're going to be the 5 key points that we're talking about. Half of the period and then those middle points as well. Well, at the ends of this graph, we have asymptotes, as we've seen with the parent function. So I'm going to go ahead and draw in those asymptotes. They'll sort of be like goalposts to kind of indicate where the tangent wave is going to be. So my x-axis is labeled now. To label your y-axis, here's where that A value is going to come into play. We don't have an amplitude, but it is going to be a significant point on the graph. So I'm going to go ahead and label that y-axis as 2 and at negative 2. So actually my scales are all set up now to actually plot the points to find this tangent graph. One of your points is going to be at 0, 0. So I'll add that point right there. If I go over to pi over 12, I'm going to go up to 2. That's the significance of that point right there. It tells me a coordinate. And then similarly, if I go to negative pi over 12, I'm going to go down to negative 2 for that point. So those are going to be the 3 points we plot. We're going to count the asymptotes as kind of a second or a fourth and fifth point. So I have the 5 points. And then to graph this one, your wave is going to start close to the asymptote, curve through there, try not to draw over the numbers if you can, and then it's going to approach the second asymptote and then curve back up. I'm going to add arrows to this because this graph does go up and down forever. So there is one period. Now this wave would of course repeat forever to the left and right, but there is one period of what this graph will look like. And I'll show you one more example over here. We'll start out the same way. I'm going to note that my A value is 5, not the amplitude, but the A value is 5. Also, because I have a negative sign right here, this graph has been reflected. So my wave is going to look upside down of the one we just did. It's going to be flipped over the x-axis. The B value is pi, which is not the period, but it will help me find the period. To find the period of a tangent graph, that is pi, the normal period, divided by whatever our B value is, which turns out to be pi this time, and pi divided by pi ends up with just a period of 1. So using this information, I should be able to get a sketch now of one period of this tangent wave. So again, I'll start differently than sine or cosine by showing in front and back of that y-axis. The graph is going to straddle the origin. I need to then identify my x-axis numbers. Well, even though the period is 1, since I want half to the left and half to the right, the period is just, or this tick mark is going to be half the period. So half of 1 gets me a half. And then over here we'd have negative 1/2. The total distance between there is 1, which is how I'm going to show the 1 period. Okay, so I'll label 0 for the origin, and I also want half of the halfway point. Half of a half is just a quarter, so 1/4 and negative 1/4. And yes, I would want to see every single one of these points on your graph. For your A value, then we can label the y-axis. It's going to be at 5 and at negative 5. Not the amplitude, but that number will be significant. Okay, so to actually now get my graph, I'm going to go ahead and draw my asymptotes in at the ends. So there'll be an asymptote at -1/2 and an asymptote at 1/2. The graph will get close to there but not touch it. And then to plot our points, 0, 0 is still a point even though our graph has been reflected. But because we're upside down now, when I count forwards to 1/4, I'm actually going to count down to -5/4. My graph is upside down because we've reflected it with that negative sign. If I count backwards to -1/4, I'll count up to +5. And now once again, I'll kind of make my curve using those points. So I'll start high this time, close to the asymptote. I'll connect through those points as best I can, try not to make your graphs look too lumpy. And then as I approach the asymptote, my graph will start to drop again. So adding arrows to both ends, there is one period of this tangent wave.